Good morning, or good afternoon, good evening, wherever you may be. This is Greg Troutwine. I'm the editor and the associate publisher of Maritime Reporter and Engineering News and Offshore Engineer magazines. And I'd like to welcome you to the fourth in our series of offshore wind webinars, this one entitled Next Generation Offshore Wind Installation Vessels, Opportunities and Challenges. We have a great speaker lineup today with Philip Lewis, the head of Offshore Wind Research, World Energy Reports, Asbjørn Hasselbach, Manager, Technical Solutions Marine, Yasagawa, Matthew Trimbley, Vice President of Global Offshore Marine, American Bureau of Shipping, and Walter Cruikshank, the Deputy Director, Bureau of Ocean Energy Management. The format for today's webinar should be a familiar one, with a series of short presentations from each of our speakers, followed by an approximate 15 to 20-minute Q&A session, which I will moderate. Please use the message board on this platform to ask questions anytime during the presentation, but all questions will be reserved for the last 15 minutes. As history suggests, we will not likely have time to get to every question, but rest assured that your questions will be put to the panelists for answering after the fact. Also, a recording of this event will be made available to all registered attendees afterwards. To start, I'd like to welcome Philip Lewis, the head of Offshore Wind Research, World Energy Reports. Philip has close to 30 years of corporate and commercial management and strategic planning experience in senior leadership team and board positions, developing strategy, driving change, and exceeding targets within the renewable energy, offshore marine, shipping, and heavy engineering space. Philip has previously worked at Navigate Group's RK8 OSV unit and Michelin's Express Offshore's ASEAN OSV business unit, and with IMC on various roles covering OSVs, offshore EPCI, and ship repair and engineering. Welcome, Philip.
Thanks, Greg. Hello, everyone. Let me start by a quick introduction to who we are. World Energy Reports is part of the International Maritime Associates, a business consulting firm. Formed in 1973, IMA provides market analysis, strategic planning, business development, and project implementation support to clients in the energy, marine, and industrial sectors. Next slide, Mark. More than 400 business consulting and assignments, 400 business consultant assignments have been completed for over 170 clients in 40 plus countries. World Energy Reports produces multi-client studies in rapidly growing market sectors where there are wide industry requirements for up-to-date objective market information for business planning and benchmarking. And our current studies focus on offshore wind market, floating oil and gas production, and offshore gas liquefaction. And we have developed and maintained proprietary online databases and mapping services in each of these sectors. Next slide, please. So what are we going to discuss today? Well, we'll have a look at the global offshore wind forecast. We'll discuss two distinct installation segments, bottom fixed and floating wind. We'll touch on some of the drivers for bottom fixed wind installation vessel demand, present an example using the US, and then finally discuss some of the drivers for floating wind installation vessel demand. Next, please. So with the forecast, globally, we reached over 32 gigawatts of offshore wind capacity at the end of 2020. Now, to put it in context, that's less than 1% of the total world electrical energy capacity. But the growth has been sharp, with UK, Europe, and China being the major markets at the end of 2020. We expect to see 70 gigawatts by 2024, and there are targets for over 270 gigawatts of offshore wind by 2030. Next, please. Now, our position is, and our view is, we think that's going to be closer to 230 gigawatts, split between various markets. And the UK, Europe, we believe will continue to drive the international market activity. Taiwan continues delivering on clear offshore wind roadmap. The US is working through its permitting backlog, and we've seen the first project reached FID. Japan and South Korea have big ambitions, but they also have some permitting issues to develop on those ambitions. Vietnam should transition from an intertidal to true offshore market by the end of the decade. Australia will enter the market by the end of the decade. India's going through its addressing its permitting framework, which is slowing somewhat its ability to deliver on its ambitions. And Brazil has potential, but certainly some challenges. China, we see that remaining a discrete market. We don't see the vessels coming outside of China. More, actually, the vessels will move from the international market to the Chinese market as they've been doing recently. And China will work through its project backlog targeting expiring subsidies and transitioning to a more stable growth environment. Globally, near 95% of capacity additions through 2030, we believe will be bottom fixed. And there's a potential bottom fixed vessel shortage. We see peak international market demand from the middle of the decade. Also, there's going to be an emergence of commercial scale floating wind in the second half of the decade. And that has a completely different set of installation challenges. And long-term growth of offshore wind, we believe, is linked also to addressing variability issues, and that's through battery systems or power-to-X solutions, turning those electrons into molecules such as hydrogen as a positive energy carrier. Next, please. So, as we mentioned, there are two distinct segments, bottom fixed and floating. The blue table shows the major activities and major vessels that you would see on a bottom fixed project, and the grey table is those for a floating wind project. So on the blue table, the bottom fixed, you've got foundation, substation and wind turbine, T&I, transportation and installation, cable and commissioning. And that will be mainly undertaken by wind farm installation vessels. Now, these are heavy lift crane vessels, but with the addition of large decks to carry the foundations from marshalling yards and factories to site. The heavy lift crane vessels themselves that don't really have that big transport capability. WTIVs, wind turbine installation jackups, cable lay vessels and barges, rock dumping and fault pipe vessels for scour protection, feed of spreads in the markets like the US, and SOVs for commissioning, and also long-term O&M. But in the floating wind side, we see different processes involved. You make the turbine to the substructure, generally at quayside or in a protected port area. The major offshore installation steps are mooring, pre-lay, towing, hookup and final commissioning, and cable lay. Now, the cable layers may be some from the traditional offshore wind segment, but you'll see a lot more of the traditional oil and gas vessels deployed on floating wind, but the very largest of those, AHTs, AHTSs, MPSVs, and subsea OCVs. Next slide, please. So let's just quickly touch on some of the drivers for bottom fixed installation vessel demand. Well, there's a rapid technological evolution going on, and this is driven by efforts to drive down costs. But this means that this has impacts on vessel specifications, and it also shortens the lifespan of vessels. We've seen technical obsolescence, or we see technical obsolescence coming up from an installation perspective of around 15 wind turbine installation vessels in the international market, and a mid-decade shortage of wind turbine installation, wind foundation installation, and cable lay vessel shortages. Now, bigger wind turbines are part of this speed of change. Now, that leads to heavier and higher turbine component lifts, larger foundations to support heavier loads, longer array cables, so more cables to be laid and carried. Deeper water depths, generally we see as a trend, and that leads to heavier and higher monopile lifts and more jackets. Wind farms being built further offshore, that leads to longer transit times for vessels, so you want them to be more efficient with bigger decks, longer export cables, and more large HVDC, high voltage direct current transmission. Now, higher capacity cables is also a trend, and that leads to increased weight per meter of cable, and it drives larger cable lay vessel equipment. And also, given some some of the historical problems we've seen on offshore wind projects, avoidance of cable damage is important, and that means protecting the cable during laying and from dragging once it's laid, and that means specific purpose-built cable layers and cable burial protection. Next slide, please. And as we enter new markets, we're seeing increasing challenges of soil conditions, especially for the wind turbine jackups. Back one, please, Mark. Poor soil conditions, and as we said, these impact predominantly wind turbine installation vessels. Part of the solution we've seen is deploying DP3 vessels or semi-subs for wind turbine installation, which is not traditional method, but because of these poor soil conditions in certain markets. a big trend is the increased demand for environmentally friendly vessels. Now, there's not one approach apart from a general trend for emissions reduction, reduction of environmental impacts. But from a vessel owner point of view, this can be tier 3 engines, diesel electric, hybrid battery systems, vessels that are LNG, biofuel, e-fuel ready, as well as other fuel saving technologies. Large projects and project clusters have been seen certainly in the European market and the US market, and that gives scope and scale for efficient vessel planning and commissioning, and supports the demand for commissioning and O&M SOVs. Local content preferences are becoming more important factor to keep in mind, especially in places like Japan, the US, and Taiwan. US projects, I mean, we'll see the need for feeder vessels and vessels that can carry 100% project requirement when coming into the US, and we'll touch on that a bit later. Increased O&M demand, operations and maintenance demand, will compete for existing installation vessel supply, and alternate technologies may take away from demand for existing installation vessels. Next slide, please, Mark. So we'll use the US as an example. Now, the foundation in the US is 34 gigawatts of state offshore wind goals, 14 gigawatt plus of offtakes already, and 16 gigawatts plus in federal permitting with targets as a visible pipeline. Now, if we, on the right-hand chart there, we've superimposed that onto by developers COD date, that's commercial operation date, onto those projects in Europe and East Asia that are reached post FID or in permitted or have been permitted or in permitting. And we can see there's a peak of activity around the middle of, well, post the middle of decade, 25, 26. That's for installation. But to reach that, the activity needs to be going on 1 to 2 years before that. So there's a real challenge of matching global supply to demand. And questions will be raised of, do we need to build more vessels or deploy suboptimal vessels with the impacts on schedules and costs? Or will we see project delays or a combination of all three? Next slide, please. And, staying with the US, where we have the Jones Act, which creates opportunities for US companies, but also challenges for project developers. And we're saying that in the context of the previous slide where we talked about the global offshore market. Only one Jones Act wind turbine installation vessel is currently in building. Several are discussed, but no other orders are currently being confirmed. No Jones Act wind farm, wind foundation installation vessel or large cable layers have been confirmed either. Feeder solutions have weather sensitivity, safety, productivity related challenges. Several of the largest international wind turbine installation vessels and wind foundation installation vessels are already booked on 2024 to 2026 work in Europe and East Asia. And there's a shortage of large cable layers, both barges and vessels, forecast in the international market around the middle of the decade. So that's all got to be kept in mind when you're looking at each individual market. Next slide, please. Just to wind up, let's have a look at floating wind. There's something different to bottom fixed wind. And as we mentioned earlier on, there's a different installation model for floating wind than bottom fixed. Quayside assembly of the turbine substructure. You've got to store these turbines once they're assembled at port if there's bad weather. And don't forget, these are turbines with 220, 240 meter rotors. So these are very large structures. Now, the process is different from bottom fixed wind. As we say, you've got the offshore campaigns are mooring prelay, towing and hookup. And the assets or the vessels used are different. And that includes the largest HTs, HTSs, MPSVs, and subsea OCVs. Cable lay, yes, we'll see some of the traditional bottom fixed offshore wind cable layers involved, but there are, especially for array cables, you have challenges and solutions still being developed for dynamic cables used in floating wind projects that require disconnection for O&M. And O&M itself is also a subject that's still being worked on for solutions for commercial scale projects, whether you do that maintenance in situ, floating structures offshore, or to tow those structures back to port for the above water components. And then also you've got the challenge around the acceptable solutions for in-water mooring inspections being developed, and the ABS is certainly very happy, I'm sure, to talk about that as experts in that area. Now, one of the areas just want to touch on, just to give an order of magnitude of size we're looking at with floating wind, and when we talk about the moorings. And I've taken some figures from Equinor for an example. If we look at a deep water FPSO, that's one unit. That might deploy, let's say, 16 anchors. And for those 16 anchors, you probably need to deploy around about 40,000 meters of mooring line. But a 1 gigawatt floating wind farm, so that's 66, 15, 16 megawatt wind turbines, which are the sort of scale of projects being looked at towards the end of the decade. You'll be seeing over 200 anchors plus minus. Now, that's based on at least 3 mooring lines for each floating structure. So that's at least, we would say, 200,000 meters of mooring line per project. So you can see the quantities involved are substantially different than, let's say, a large FPSO. So that's going to drive demand for those large anchor handlers, HTSs, MPSVs, OCVs towards the end of the decade. And we certainly see a big shortage of both vessels and skilled crews in that to meet that floating wind challenge going forward. So just to summarize, there's a lot of wind capacity plan driving vessel demand. There are new markets for offshore wind with new challenges, such as we said, local content, soil conditions. There's rapidly evolving technical drivers for bottom fixed wind. And that's both an opportunity to new build and a risk of new building based on the speed of technological change. You know, you've got to get that right. Mid-decade shortage of bottom fixed wind turbine, foundation and cable lay installation vessels is forecast. Commercial floating wind projects will be installed in the second half of the decade, and that brings those new challenges and a new installation process. Next slide, Mark. And just leaving that there, just to let everybody know, our latest report has just been issued on the market, available on our website on the US offshore wind market. If anybody would like information on that, please do contact me or look at our website, www.worldenergyreports.com. All the information about the report will be there, and we'd be happy to take further questions on that. Thank you very much.
Okay, Phil, thank you very much for that. Insightful as always. We're going to move right along to Asbjorn Hasselbach, the Manager of Technical Solutions, Marine, Yassgava. Asbjorn is leading the team in engineering marine drive solutions, frequency converters, and rotating machinery, which are in use today with the utmost reliability on vessels throughout the world. Before joining his company, Asbjorn worked for Aker Governor Electro AS in Norway to develop frequency drives and perform sea trials and commissionings. Welcome, Asbjorn.
Well, thanks, Greg, and thank you, Philip, for a very good presentation. I agree with quite a lot of. Well, actually, I agree with everything you said. So, next slide, please. So, how can I convert from offshore supply to wind support? Because I think that quite a lot of the vessels that are being used or are not being used in offshore today, we can change and we can convert it to wind support. Next slide, please. So this is a perfect example of one vessel from Solstad, a Norwegian ship owner. Earlier it was a construction support vessel, and now it's an operation for Ørsted outside of Taiwan. It has accommodation for 116 people and also a big crane. So the only thing that they needed to do was to install a gangway to use this. Next slide, please. So then looking more onto new vessels. How can we do this with newer vessels? And one thing that we can see that there is a large power need in these. Next slide, please. Very happy to see that you also used Fred. Olsen vessels in your presentation, Phil. This is Bold Tern from Fred. Olsen Wind Carrier. It has our drives, frequency converters inside it, controlling the propulsion. And this is all built and designed for an offshore wind farm installation, but it has an AC switchboard. Next slide, please. So this is more of a conventional solution. But one of the big challenges here, and I spoke to quite many ship owners last week, and they were saying the big challenge is how can I use the energy from the cranes? They can see that it goes, everything is hydraulic almost, and it goes into a system and they need to cool it. So they have these box coolers all around the vessels, creating a lot of maintenance and a lot of issues. They want to use that energy. But the good thing with an AC solution is that it's a known system. So there are several suppliers, but it has low efficiency compared to a DC hub, and it's not ready for future energy sources. Next slide. So that's why we should change. So this is our concept for DC distribution. We believe that this is a much better solution, and it can easily compete with medium voltage installations. Everything is on the main things are connected to a DC, and the cranes can be connected. If you look at the bottom left, there's a DC switchboard, and you can connect the cranes and big energy sources or the big energy consumers that will also like to get rid of energy to that DC switchboard, and you can use that energy all around in your vessel. This is next generation offshore wind installation vessels with this type of installation. This is all possible if you have an electronic controlled DC bus. You can see the one small marked EBL connecting the different orange or pink boxes. And they react so fast that if you have a big problem with the cable going between the boxes, everything will be disconnected within 10 microseconds and operation will continue. Because we all know that if you are going to install a big piece of equipment high up in the air, you want everything to continue. You want it to continue to run no matter what. You never ever want it to stop. Next slide, please. So the good thing is that you can get the entire package of generators, motors, DC hubs from Yaskawa Environmental Energy. The switch. Next slide. So what are the advantages of a DC hub? Well, it's a plug-in. So it is prepared for new energy sources, because I think if you build a vessel today, you need to be prepared for what is coming. Do we know exactly what kind of nice, environmentally friendly fuel systems or energy sources we will have in 5-10 years' time? And we need to be prepared for that. Is it a fuel cell? Maybe with hydrogen? Maybe, I don't know, but it has to be prepared for it. And one of the good things is that you eliminate transformers or downsize them significantly. EBL in this slide stands for electronic bus link, that I talked about, and that gives you higher redundancy. The electronic bus link is approved for DP3 operation. You can run with a closed bus tie, and we have tested it, and it is running on vessels today. So we know it's working. It's not something that we are developing or that we have lying around somewhere on a desk. It is installed, it is working, it is on operation. Talked with a guy that was technical manager for the vessel on Friday, and he is very happy. And because you have guaranteed selectivity, you have increased safety also. And it is installation flexibility. You can place your DC hubs anywhere. Next slide, please. So as a result, we have installation with superior reliability and flexibility to run on future power sources. Next slide. So we have more than 1,300 drives and about 100 machines already delivered for marine. Our biggest customers, Vitek, Wärtsilä, and Berg Propulsion. Next slide, please. So our focus applications: electronic bus link, electronic DC breaker, protecting the different modules, DC distribution, and genset, direct drive electric propulsion, and inline shaft generators. Next, please. And of course, when we are talking about wind installation vessels, we cannot skip the fact, I have to just mention this very shortly, I promise you, that Yasko Environmental Energy, we are delivering generators for wind turbines and have been doing since 2006. This year, we have passed over 20 gigawatts of environmental energy technology delivered worldwide, mainly for wind, but also for marine and for industry. So, next slide. As a conclusion, DC hubs allows you to easily reuse crane energy. Get rid of those big box coolers, use that energy, have a much more environmentally friendly vessel, and make everybody happy. The electronic bus link allows you to connect several DC hubs in a link configuration. And we have a long track record of delivered both drives and permanent magnet machines. It's proven experience, and it is future flexible. It is ready for any new electric energy source and loads. Next slide. So this is the last one. Thank you for listening to me. And please feel free to contact me if you want to have any more information. And also please sign up for our marine blog. Thanks.
Asbjørn, thank you very much for that excellent technical presentation, which is a perfect lead to our next speaker. Next up is Matthew Tremblay, the Vice President of Global Offshore Markets at ABS out of the corporate headquarters in Houston. In his current role, Matt holds the global responsibility for strategic planning and client development within the offshore market sector. Throughout his 25-year tenure at ABS, Matt has served in various engineering and leadership positions throughout the US, Asia, including the Pacific Division Vice President and Operations based in Singapore, and the Vice President of Engineering for ABS Americas Division. Welcome, Matt.
Thanks a lot, Greg. Appreciate it. Kicking things off, I'd like to say, I'd like to echo Asbjørn's comment that ABS's views are very well aligned with what Philip presented on the market outlook. And as well, I'd like to say that, something I'm going to comment on in the presentation is aligned with Asbjørn's point that, the technology that's being installed on these wind turbine installation vessels and the vessels supporting the wind market is definitely advancing. And we're as an industry, adopting some of the latest technologies that are being employed throughout the industry. So when we start off on the next slide, I'd just like to start by highlighting several trends we see across new developments within the wind farm energy market. Firstly, the industry is seeking continued cost reductions through larger turbines. We're all aware of this with rated capacities of well above 10 megawatts at this point. Second, we heard plenty of this we heard this point very clearly from Philip, that the demand for the wind farm support vessels is expected to increase in order to support planned construction projects for both fixed and, in the future, floating offshore wind farms. And third, the floating specifically wind energy project pipeline itself is continuing to grow. And we got a good view of that from what Philip shared with us today. The emerging challenges associated with offshore wind farm developments as well as its supporting vessels can be kind of categorized in the four aspects. Firstly, the technical challenges to design these complex facilities. Second, the operational challenges to optimize operating expenses. Thirdly, the environmental challenges to transitioning into creating an even lower carbon footprint of our fleet. And lastly, the regulatory challenges tied to compliance with the international and local regulations. Go to the next slide, please. From a US perspective, but also taking a global view, we have both an opportunity and an obligation to leverage the experience we've gained building up the fleet in Europe over the last 10 years. As we look to build the next generation of wind installation vessels, this experience will be critical to the design and operations decisions we're making in the US and around the world over the next 5 to 10 years. ABS has been classing specialized wind turbine installation vessels for the last decade. You can see here a list of some of the ABS class installations currently operating in Europe. The existing wind turbine installation vessel fleet has crane capacities from about 800 to 1,600 tons and leg lengths from between 72 meters and 106 meters. But as we look into the future, the newer wind turbine installation vessels can install larger turbines of 9 megawatts and above, with crane capacities ranging from 1,600 to 30,000 tons, and are capable of lifting to the increased turbine heights. They operate at depths from 65 to 80 meters, with accommodations for between 100 and 130 people. And the deck spaces are also increasing to transport multiple larger turbines. You know, at ABS, we've taken the lessons learned through just some of this experience that you see here and applied it to the work that we're doing on the next generation of offshore wind turbine installation vessels. So please, let me take just a moment to highlight two of these projects. If you go to the next slide, please. Now under construction by Keppel Amfels, in Texas, which is also undertaking the engineering and procurement for Dominion Energy. This is a 472-foot vessel that's been designed by Gusto MSC to handle turbine sizes of 12 megawatts or larger, and also be able to capable of installing the foundations for turbines and other heavy lifts. To be named the Charybdis, this vessel will have accommodations for up to 119 crew and wind farm technicians. So highlights the start of the progress of the construction for vessels dedicated to the U.S. Jones Act fleet. On the next slide, the next vessel I'd like to highlight has a very international pedigree. Named the Green Jade, this vessel has been commissioned by CDWE, which is a joint venture between a Taiwanese company, CSBC, and the Belgian offshore contractor, Demi. It'll be built at CSBC's shipyard in Taiwan for delivery in 2022, and it will be deployed into the region's offshore wind market. This is a key development for the region's offshore wind capability and for the Taiwanese shipbuilding industry. Just over 216 meters in length and with a crew of up to 160 people, the Green Jade will be equipped to handle the heaviest monopiles, jackets, and turbines, and feature a 4,000-ton crane capacity, as well as DP3 capability and dual fuel engines. The Green Jade features a waste heat recovery system that converts heat from exhaust gases and cooling water into electrical energy. It's this kind of innovation and incorporating solutions for more environmentally sustainable operations that shows we're learning from other projects and innovating for the benefit of the industry as well as the environment. Next slide, please. As we think about the vessels that'll be supporting the offshore wind market, we're all working together to develop solutions to control costs while maintaining safety and efficiency in the supply chain. There are technology enablers, such as hybrid power systems to improve energy efficiency. This could be both dual fuel systems using LNG or hybrid energy storage systems using batteries. There are many benefits to the use of hybrid power systems beyond the reduction of CO2 and NOx emissions. Systems are being built today to enable redundancies in power supply, like we heard about just earlier from Asbjørn, as well as help optimize engine loads that have been shown to reduce operational costs through lower fuel consumption. There's also operational strategies that we can employ to support the energy transition. These approaches can enhance operational performance and drive efficiencies. By executing our operations more efficiently, we can reduce our required manning and our time spent impacting the environment and those around us. Other technology solutions include smart functionality using sensors, as well as remote survey options to increase efficiencies and safety and improve operational performance and reduce cost. And of course, we'd be remiss if we didn't also address the digital tools being applied today that are constantly evolving and bringing new capabilities we wouldn't have considered only 5 years ago. Digital insights support improved decision-making, allowing you to better understand your operational profile and lead to more effective asset integrity management. There's certainly room for improvement through instrumentation, data collection, modeling, and analytics to move to reliability-centered maintenance strategies and risk-based inspection planning and repair. Offshore wind farms are very capital intensive. Upfront investment costs make up the majority of the total lifetime cost of an offshore wind farm, which is quite high in comparison to other electricity generation technologies. And we need to capitalize on all these technology advancements to bring that capital, to bring value to that capital investment. Next slide. ABS continues to collaborate with industry on all types of assets, from the offshore wind turbines themselves to the vessels that install and support them. We're here to provide practical advice to the fleet on adopting regulations, on alternative energy sources and hybrid power strategies, and all means of leveraging technology to improve safety. ABS shares this experience with the industry through publications such as our Guide for Building and Classing Wind Farm Support Vessels, our guides for building and classing both fixed and floating wind turbine installations, and our 2 white papers on the intricacies of the U.S. wind market. Next slide. So just in closing, I'd like to thank everybody for the time today. ABS is standing by as the class society to support the wind installation market as it moves forward, and looking forward to hearing everybody's questions after the presentations. Thank you.
Matt, as always, thank you for your technical insights there. I can concur. There are some amazing vessels being constructed with some amazing new capabilities. We look forward to following up with you. Last but certainly not least, we have Walter Cruikshank, the Deputy Director, the Bureau of Ocean Energy Management. As Deputy Director of BOEM, he oversees the administration of programs that manages the development of the nation's offshore resources in an environmentally and economically responsible way. These programs include leasing, plan administration, environmental studies, National Environmental Policy Act analysis, resource evaluation, economic analysis, and renewable energy program. Welcome, Walter.
Thank you, Greg. Good morning, everybody. On behalf of Bureau of Ocean Energy Management, or BOEM, I'd like to thank Maritime Reporter, Engineering News, and Offshore Engineer magazine for inviting me here today. I'm really looking forward to this conversation. This is not a typical audience for me, but it's really a critical one as we think about how offshore wind is going to grow in the United States and the various pieces of the supply chain that will be needed to be able to make that happen. And my role today is a little bit different than what you've heard so far. I'll be less technical, but I'm here to talk about the federal vision for offshore wind and what we are doing at BOEM to try and advance these efforts. For those who aren't familiar with us, BOEM is that part of the Department of the Interior tasked with managing the development of energy and mineral resources on the U.S. Outer Continental Shelf in an economically and environmentally responsible manner. We manage oil and gas, renewable energy, as well as sand and gravel resources used for coastal restoration projects. And of course, we're the lead federal agency for offshore wind, which is our focus here today. President Biden has made increasing responsible renewable energy development on public lands and waters a priority for the administration. This past spring, Secretary of the Interior Deb Haaland, along with their counterparts from the Departments of Commerce and Energy, set an administration goal to deploy 30 gigawatts of offshore wind by 2030, which would create nearly 80,000 jobs. BOEM is playing a critical role in implementing the administration's strategy. To date, we have leased 1.7 million acres on the Outer Continental Shelf. We have 18 commercial leases in the Atlantic, stretching from Cape Cod to Cape Hatteras. And we plan to move forward with additional lease sales and complete the review of at least 16 construction and operation plans by 2025. Construction and operation plans are the final document that needs our review and approval before a project can be built. And these 16 construction operation plans represent more than 19 gigawatts of clean energy for the nation. Now, BOEM has made significant progress toward achieving these goals. In May, we took the historic step of approving Vineyard Wind offshore Massachusetts to be the first commercial scale offshore wind project in the United States. In August, we published the final environmental impact statement for South Fork, a project that will connect to New York, and if approved, will be the second commercial scale offshore wind project approved under the current administration. And last week, we announced we're initiating review of Atlantic Shores project off New Jersey, which will be the 8th project on which we formally initiated the review process over the last 8 months, and there are more expected to come later this year. We're also preparing for additional lease sales. This spring, we published a proposed sale notice for the New York Bight, an area of particular high demand given the ambitious offshore wind goals of New York and New Jersey. Also in the spring, we came together with the Department of Defense and the state of California to announce an agreement on areas to consider for offshore wind lease sales off California's northern and central coast. And over the summer, we met with our intergovernmental Renewable Energy Task Force to discuss how we might move forward with the lease sale off the Carolinas. And we expect in each of these areas, we can move towards a lease sale in the near future. We've also begun exploring other opportunities as well in the Gulf of Maine, in the Gulf of Mexico, and offshore Oregon. To make these opportunities a reality, BOEM is focused on driving progress on reviewing projects and advancing lease sales. A critical part of this effort is enhancing our process to create greater certainty for industry, state and local governments, tribal nations, ocean users, and other partners and stakeholders. We need to create both an efficient and effective process for reviewing plans to develop existing leases, and an inclusive and expeditious process for identifying new areas for potential future lease sales. As part of these processes, we are going to continue to engage in conversations and develop strong partnerships with states, local communities, and tribal nations, as well as with ocean users and stakeholder groups, to try and develop solutions that will meet the needs of this new industry while supporting the already existing activities in our oceans. We're working with all these parties to try and ensure early communication and manage potential conflicts. And we will continue to prioritize protecting marine ecosystems and the use of science and traditional knowledge to guide our decisions. Our desire to move forward with offshore wind will not outpace our steadfast commitment to do this right. And as we do so, there will be many benefits. By meeting our offshore renewable energy goals, we expect we will increase the confidence of those who would invest in developing a domestic supply chain to meet the demand of planned projects. The federal government is not and shouldn't be the only parties out there advancing offshore wind industry, and we see efforts of state and local governments, industry, and other stakeholders to create a collaborative atmosphere for advancing offshore wind and providing healthy economic development. As has already been mentioned by this panel, as the industry grows, it's going to need larger turbines located farther offshore and in deeper water. And building these projects will require additional investment in all types of vessels, in ports, and in infrastructure to accommodate these projects. And we're starting to see some of these investments come to fruition. A couple of speakers have already mentioned a Jones Act compliant offshore wind installation vessel being built in Texas using some 14,000 tons of domestic steel. Other Jones Act vessels are being designed and developed as well. There's conversations around another wind turbine installation vessel. There are crew transfer and service vessels being constructed. Feeder vessels are being designed, as well as scour protection vessels, but certainly not enough yet to meet the demand for projects that we see coming over the rest of the decade. State and local governments and the private sectors are also investing in port infrastructure, creating staging areas for installation, sites for storage and assembly, hubs for logistics, operations, and maintenance. And we are seeing these ports being built in every state from Massachusetts down to Virginia. And on the manufacturing side, we see facilities are being built for offshore wind turbine foundations, monopiles, towers and transition pieces in Maryland, New Jersey, New York, and Rhode Island. We see cables being contracted in South Carolina and in Connecticut. And the first US-built offshore wind substation will be built in Texas. So many of the components necessary to foster this type of investment in a favorable business environment are already in place. We have a mature industrial base, extensive manufacturing experience, highly trained workforce, and a history of offshore energy development. All of these factors, combined with the growing nationwide interest and demand for offshore wind, indicate that the country is well positioned for a transition to renewable energy. But these environmental and economic benefits will only be realized if we all come together to ensure that this potential development is considered and advanced responsibly. Meeting our goal of 30 gigawatts by 2030 will create numerous opportunities, not only for the offshore wind industry, but also for maritime and other service industries that will support building 30 gigawatts by 2030. And I look forward in the question session to discussing these opportunities and learning from both my fellow panelists and those of you in the audience. Thank you.
Excellent. Thank you, Walter. Thank you, Matt, Asbjorn, and Phil for excellent presentations. I'm going to move quickly on to the Q&A period because our time is ticking. And again, Phil, thank you. I see Phil has already filled up the Q&A panel with some written answers, so that's appreciated as well. One question I want to pose specifically to Matt. Matt, it was, I forget how many years ago, maybe 3 years ago, we were down in New Orleans and ABS had an incredible panel conference on offshore wind. And we've been talking about this issue of building ships and having enough ships to do things. And so the first question that came in is, why isn't the US market seeing more tenders for installation vessels and SOVs?
Good question. I don't why aren't we? I think one of the interesting things we can think about it, and one of the questions that we were getting in when we were in New Orleans in 2019 was, what's the opportunity for utilization of the existing fleet for some of these offshore wind activities that are going to be coming up in the United States. And as we get closer and closer to that peak that Philip told us about in 2025, I think the likelihood the necessity of utilizing maybe some of the existing fleet because new construction won't be prepared in time gets higher and higher. I do expect that we're going to see some new orders over the next 6 months. And that would give us some time to prepare for that peak and that Philip was telling us about. But I think there's a bit of a chicken and egg thing going on right now as far as the charters becoming available versus the vessels waiting for the charters to before they contract new construction.
Okay. Phil, you'd like to add a little something? Phil, you're on mute. And I didn't put you there.
For once. Just adding to that, and sort of looking at maybe in the global context as well. As we said, there's indication of peak activity around the middle of the decade, but what you can see from some vessel owners who are being asked to, with the big vessels, invest 200, 300, 400 million plus in a vessel. They're worried about the speed of technical development on technological change. As we've seen, wind turbines, at the moment we're installing 9.5 megawatt, 10 megawatt platforms, and that's great. Moving to an 11 megawatt turbine. In planning documents and planning applications, people are already seeking permits in Europe, in the US for up to 20 megawatt turbines. People are planning to have to install those. So if you're a vessel builder or a vessel owner, one of the challenges might be, well, do I make the call now, build a vessel and get a big bang for my buck sort of around the middle of the decade, but then maybe face some utilization challenges towards the end of the decade where I have to upgrade my vessel with new cranes, new jacking systems if it's a wind turbine installation vessel, or will I be in different geographies where maybe I can't jack down and I need a vessel? And I'm talking for the wind turbine side. The foundation side has some challenges, and cable vessels also have some challenges. But what I've seen some vessel owners also say is they've actually held back on vessel commitments because of some deferments in project FIDs. And this is not specifically US, this is a global issue where there are all these plans announced. There have been these auctions, there have been these projects, but there are also challenges to permitting projects, as Walter says, it has to be a thorough project to make sure that all eventualities are looked at, and that does take time, and sometimes that leads to questions and delays, and that backs up the requirements. At the same time, we're all looking to bring on 200, 220, 270 gigawatts of capacity totally by the end of the decade. Something's got to give, but the owners are basically saying, well, some owners, I should say, I'm not going to build a vessel at the moment because I'm not sure. Or like you saw in your magazine the other day, Vineyard put out the announcement of their new wind turbine installation vessel, Atlas C-class vessel, capable of installing 20 megawatt turbines. That, in theory, is a future-proof vessel, and we hear the words future-proof. So some owners will make that plan to build. Some will make the upgrade, like you've seen for the Vineyard project, where there's going to be a foreign flag wind turbine installation vessel that's going to go through an upgrade to be able to install in the US, and it'll be supported by Jones Act feeder spread. The Charybdis that Matt was talking about earlier, that's already booked on Dominion's project, which is Zone Plus, Ørsted's Northeast Cluster projects. So there's dovetailing 5 major projects for one vessel. The Vineyard project, that has other clusters, other projects that could join the cluster, where you might see the sharing of the vessel. So even though the vessel years might reach a certain number, you know, this project clustering and the project economies of scale might also lead to you being able to share vessels better, which again might put off some vessel owners from making that final investment decision on a $300, $400, or $500 million asset. So I mean, there's not one easy asset, but there's a whole range of complex issues that I think are being looked at.
I agree with you. There are many complex issues. This is a question from Joan Bondareff. There's actually 2 of them. I'm going to kind of combine them, and one of them is targeted to Walter. It's Joan asks, why doesn't industry propose a new model for the Title 11 loan guarantee program as directed to offshore wind vessels, and specifically for Walt? Why not reach out to the Department of Transportation for a new Title 11 loan guarantee program for OSW vessels? They should be a part of the program too.
Yeah, we actually are talking across government, Department of Transportation, Commerce, Energy. To get to where we want to go, it really does take a whole of government approach, and we are talking with other agencies about what programs they have and what more can be done to try and spur the development of the supply chain and vessels, vessels to move forward in this country. I don't have any answers yet in terms of what we might be able to do, but those conversations are going on.
Excellent. Okay, so let's see. Good. A question: does anyone expect to see new U.S.-based developers participate in the upcoming New York Bight leases? If yes, any guess on who will compete?
I put some answers in the panel on that already.
Okay. Does anyone like to add to that, or?
I will just say we know it's going to be a very competitive auction. I know that there are new companies coming in that have not bid on us before. I'm not at liberty to share those yet, but it's we'll likely see more participants in the New York Bight auction than we've seen in any previous.
Okay.
Yeah, I mean, Greg, I just said on the panel, you obviously had the call for interest and nomination, call for interest, the expressions of interest a few years ago, where some existing developers and 1 or 2 additional developers had expressed interest, but at the moment, as Walter says, no formal announcements by people. Therefore, it's rumours rather than sort of more speculative than confirmed. But European developers and European oil and gas companies will feature strongly there, I would imagine, either through their US subsidiaries or in their own right.
Excellent, and thank you. This one might be a little more for the technical members of our panel. We often discuss the European model versus the US model, and the Europe has a generation's lead on the development, installation, and life cycle maintenance of offshore wind. Sticking with the WTIV theme, and some of the advanced vessels under construction, what can we learn from the European model, and what assets or capabilities do we have that we can do it better?
Well, I think that one thing that we need to learn from what we have done in Europe is that you need to be flexible. You need to have the possibility to change your vessel, as we are now seeing with one of the Fred. Olsen vessels that they are now installing in Ukraine, and I believe they have to be able to do that, and because things are getting bigger, and I can understand the vessel owners. Should you really aim for the biggest that might come, or should you aim for what you have today? That's difficult. Then you need to be able to convert.
Yeah, just to expand on that, I think, as Bjorn's point about flexibility, it's in the U.S. we have to recognize that this is not the same old oil market that we've been working with in the supply vessel and support vessel sector for the last 30, 40 years. It's a new market with new goals, new drivers, and approaching that client base with what we've always done around here in the Gulf of Mexico. That's not going to fly over the next 10 years.
Just adding to your earlier point there, if you look at the wind turbine installation fleet at the moment, let's say over 600-ton cranes, there's 17 active vessels at the moment. 6 of those are already scheduled for upgrades, because basically they're going to be, and I use this word carefully, technically obsolete. If you start going to if you ask them to do a 15 megawatt turbine or a 20 megawatt turbine, they can't. Therefore, they upgrading. So, and these are vessels that are mostly, apart from one, no older than 10 years old. Most of them are significantly younger than 10 years old, and they're already going through major upgrades. So it gives you an indication of the speed of technological change. Excellent. And that's happening not just with wind turbine installation vessels, but with cable layers as well. All of those trends we mentioned are driving for much, much bigger capabilities and making earlier vessels effectively redundant for their initial design purpose.
Excellent.
Not redundant, I should say, but for their specific purpose.
Okay, thank you very much, Phil. We have a dwindling time and a couple more questions from John Artson. What about new solutions for heavy maintenance jobs during O&M? WTIVs are expensive to bring in for the occasional heavy lift for work in the nacelle or on the rotor. This is where the global industry needs solutions.
I mean, when you're having to do a blade exchange or a major component on a nacelle, you're going to have to get a crane that's big enough to actually get up there. And that does basically mean bringing out a wind turbine installation vessel that has the necessary crane to do that. Yes, you can bring in a semi-sub or a DP3 vessel, but their day rates are often even going to be higher. And that is one of the challenges. The supply-demand balance people are looking at the moment is for installation. It's not taking into account those. I mean, we're modeling the requirements for O&M, but this is unplanned offshore, unplanned maintenance where you need to bring in a wind turbine installation vessel to change out blades that have been damaged or change out major nacelle components. But until you have those self-erecting solutions that are being looked at, that disruptive technology, you're still, in many cases, having to bring in a crane that can lift to that height, to that weight. Limited choice. It is expensive.
Okay. Is there anyone like to add to that, or should I move on to the next one? Okay. This one specifically is for Walter. How do you see the lawsuits against Vineyard Wind impacting the industry?
I think the industry should be watching them closely, but there are a lot of projects in the pipeline right now, a lot of interest in acquiring new leases. And I think that the folks that are moving forward are pretty confident that we'll either win those lawsuits, or if the court finds a flaw, it'll be something that will be easily fixed. That's really sort of been the history across our programs, that almost everything we do gets sued by somebody. But generally, if there are any findings, they're really fairly narrow technical issues that we can go and fix with an updated environmental impact statement, for instance, that allow projects to move forward. I think people will be interested to see what does stick and how much work we'll have to do to fix anything that does. but I'm not really seeing any impact on the desire of the companies with leases to move forward with their projects.
Thank you, Walter. Those are words to live by. I'm just going to have one more question because I promised everyone a hard stop at an hour, and I've already gone past this. You cannot talk about offshore wind without discussing the Jones Act and its various components, and depends on where you come from, how you see it. And one of the questions, excuse me, in this fast growing market segment, I see the Jones Act as an extra hurdle for the US offshore wind market to overcome in order to help keep up with the pace of developments globally. Are there any plans for relaxing the Jones Act requirement?
I would not expect there to be any relaxation of the Jones Act requirement. And I don't know that I necessarily see the Jones Act as a hurdle. I see the Jones Act as a means of promoting the US market. And that's a good thing, at least for me, coming from the US. But I would expect that the Jones Act is something that's here to stay, and it is something we understand clearly, and we can start planning our project development around a robust Jones Act for years to come.
And I would agree with that. To the extent we're seeing vessels and shortages are not just a US issue, it's a global issue. And so investment in vessels has to be global, and there's no reason some of that shouldn't be in the US with Jones Act compliant vessels. And I think that, you know, the developers here have known about that requirement and been planning for it for quite some time.
Okay, well, I think investing in new vessels is a spectacular place to cut this off and let it go. We had a couple more questions. As I told the audience from the start, we will put the questions out to our various panelists, and we'll leave it up to them to respond to you if prior history suggests it will be done. So again, we very much thank you, all of our speakers, all of our attendees, for again coming together to discuss this very interesting industry. Thank you very much.
Thank you.
Thanks, Greg.
Thank you.